sketching absolute values. So by now we've looked at sketching a lot of different functions, but here we're going to look at sketching absolute values. And to do this, we're going to use our knowledge of sketching functions that we already know how to sketch. So let's look at just y equals x. So sketching y equals x is just going to be a straight line at a 45-degree angle to the x-axis. So this is y equals x. What about sketching y equals the absolute value of x? So to do this, we think about our graph without the absolute value, which is y equals x. And we sketch that just like we did. But when everything's wrapped in an absolute value, we know it turns anything negative positive. So that means anything below the x-axis is negative, has negative values for y, and they need to be positive. So anything below the x-axis needs to get reflected about the x-axis. So all of this part below the x-axis needs to get reflected about the x-axis and go up. So we get something like that. And now we can get rid of the part below the x-axis. And that would be y equals the absolute value of x. What about y equals minus absolute value of x? Well, we can apply our graph transformations, and we know that a negative in front of any function reflects it in the x-axis. So y equals negative absolute value of x will look something like that. What about y equals the absolute value of x plus 3? Well, using our graph transformation knowledge, we know that adding a constant shifts the graph up. So our original function of y equals the absolute value of x in that V shape going through the origin, getting shifted up by 3 is going to give us that V shape shifted up 3, where it's now going through 3. What about y equals the absolute value of x plus 3, where the plus 3 this time is included in the absolute value? So when everything's wrapped in the absolute value, think about the function without an absolute value sign and graph that first. So let's sketch the line y equals x plus 3. So that have a y-intercept of 3 and an x-intercept of minus 3. And we'd get something like that. And because that entire graph is wrapped in an absolute value, anything below the x-axis gets reflected about the x-axis. So all that part down there gets reflected up, and we get that. And now we can remove the part below the x-axis. Let's look at one more. Y equals the absolute value of x squared minus 4. So first, because it's all wrapped in an absolute value, we want to consider y equals x squared minus 4. So y equals x squared minus 4 is just a concave up parabola shifted down to minus 4 and cutting through minus 2 and 2. But because everything's wrapped in an absolute value, anything below the x-axis needs to get reflected up. So that part that goes below gets reflected up. So that's now going through 4. And anything below the x-axis we can now get rid of. And we get that strange looking graph.